Okay, class, now we're going to talk on reflexes. We're going to talk, this is the reflex PowerPoint file. All right, we're not going to do everything. We're just going to kind of hit high points on this. All right, so Hilton's law, any nerve serving a muscle that produces movement of a joint also innervates the joint itself and the skin over the joint. Nothing of really importance there. I'm going to get to the heart of the matter here. All right, I'm not really interested in that, so I'm going to go further. I'm actually going to I want to get to the real deal here. A lot of this we already know, so I'm not. Okay, on this here, on motor control, when it comes to a reflex, okay, first of all, let's say that a reflex is an automatic response to a certain stimuli. Let me kind of cut it to the quick here. I'm going to say that a reflex, maybe I'll just put it over here someplace. A reflex, I'm going to say, is an automatic response to a certain stimuli. So let me just kind of reflex. I'm going to say is an automatic response to a certain stimuli. Okay, we're going to get right to the heart of this. All right, so a reflex is an automatic response to a certain stimuli. What's the purpose of a reflex? A reflex is something you don't have to think about. It was developed through evolution in lower forms of animals, where you don't even have to think about it. You don't have to think about jerking your hand from a hot iron. You don't have to think about that stuff. So that's reflexes. That gives us the ability to think of higher thoughts. If we're reaching for a pencil and hit a pen, then we're going to jerk back. We don't have to think about it and say, oh, I need to jerk back. So a reflex is an automatic response to a certain stimuli. Now, we have somatic reflexes. That's involved the skeletal muscle. We have visceral reflexes. If your bladder gets full, there's a reflex to make you want to urinate. Same thing with the intestines and the bowels. So we have visceral reflexes and we have somatic reflexes, but all of them still are an automatic response to a certain stimuli. So we don't have to involve these higher structure areas. Now, the only reason I'm showing this picture here is, well, the book has it one thing, but the other thing is this. Okay, so the doctor's going to hit your leg with a hammer. If you really don't want the knee to jerk out, you could already know it's going to happen and tighten your muscles down, and it would be difficult to do it. You see what I'm saying? So you can override the reflexes. The main reflex you can override is what? Walking on hot coals, crazy it might be. The minute you touch a hot coal, what's your foot going to want to do? Pull back, right? But people learn how to walk on those coals. So you can override the reflexes if you want to. Now, lower forms of animals really can't. It's a reflex when your dog's laying on his side and you rub its side and it starts, his leg starts moving. It really can't override, doesn't have the intellect to be able to override that reflex. We do. We have reflexes and we can override it. Why? Because the cortex is informed, but it doesn't get involved. What did I just say? The cortex is informed, but it doesn't get involved. If it got involved, then what's the use of having a reflex if you go bother the cortex? All right. So I just want to get you to get a general idea of what we're talking about here. All right. So I'm going to go further and get to something here. We'll go further. All right. Now, these reflexes, inborn, intrinsic, are learned. Now, some reflexes are actually learned later. If Joe does this, I'm going to do this type of thing. So those are learned reflexes. Learned reflexes. Like in driving. You weren't born driving, but you develop some reflexes that you learned through driving experience. When we talked about the brain, skill, knowledge, and experiential. Remember, we had 3 types of knowledges. What did we have? Declarative, like you learning these facts here. experiential and skill. In the experiential and skill, you can learn new reflexes because of certain things you're doing. If you play in tennis, you learn to do certain reflexes, but that's a learned deal. Okay? And it's taken into the higher brain centers because it would be taken partly into the association cortices. Reflex arc, which would be this. So you got to have a receptor. You got to send it in and then come back out. So so it's really kind of like the feedback loop in homeostasis. Receptor, and then you come back out. But you may have some inner neuron between before you come back out. We'll see. But you got to have a sensory and you got to have a motor. You got to have the sensory and you got to have a motor. Okay? Bottom line. All right. So now, here are some reflexes, but let's introduce this first, okay, before we jump right into these real quickly, and we won't take long on these. All right. Remember I talked about the muscle spindles. Okay, we talked about tonus. Tonus was what? Resting muscle tension. When you feel somebody's arm is firm, you say, oh, you've been working out. That's a resting muscle. You have it too. The working out would just make the muscles get bigger, hypertrophy. Remember, skeletal muscles don't multiply. But we all have a certain amount of tonus, resting muscle tension. What did I tell you? If you had no tonus, the muscle is totally flaccid, right? And if you had somebody come in on you, getting ready to attack you, you don't want to go from total flaccidity to action. So you have a little tonus. So in the muscle, you have, I'm going to call these muscle spindles, which are kind of like a stretch deal. If the muscle relaxes too much and they stretch too much, then it says the muscle's too relaxed. So it sends a signal into the spinal cord, sends a signal back to contract these muscles. Vice versa. If it's too tight, you want to relax it. Then you have the Golgi tendon organ. Remember, I kept saying that's the opposite. You don't want to put too much pressure on your tendons or you tear them up. So these work diametrically opposite. The must constantly follow at the state of the muscle, the Golgi tendon, in addition to the stretch receptors. All right. So this right here, these muscle spindles are made up of fibers. We won't get into it, but essentially what happens is they're measuring the amount of stretch on this. Okay. And that's what you see here. If it's too relaxed, send something in. If it's too stretched, vice versa. Okay. And then the Golgi tendon organs are working diametrically opposed to what the muscle spindles are. All right. So now we go to the first reflex. The first reflex. Now I'm going to do it in this fashion. I made a little thing here. So we're going first to what I'm going to call the stretch reflex. The stretch reflex. And the stretch reflex basically is also the knee-jerk reflex. Okay, let me show you how this would work. You relax your leg. You're hanging off the physician's table. You relax your leg. We hit the patella tendon. Okay, in here in the quads, you got muscle spindles. The minute you hit the patella tendon, it puts a quick jerk because that patella tendon pulls on the quads. When it pulls on the quads, what's going to happen is the muscle spindle here is going to think they quickly are too relaxed. So it's going to respond very quickly. When it responds, it tightens down and the leg comes out. Simple as that. Why do we do that reflex? To check and see if you're having neurological problems or musculoskeletal problems and so forth. All right. So that's a very simple reflex. You send the signal into the cord, it synapses on the motor, and it comes out. That's a quick, simple one. That's probably one of the simplest of the somatic. Remember, these are somatic reflexes. Skeletal muscle. So what I say is, on the stretch reflex, okay, here, is monosynaptic. See, it's only one synapse. You come on back out. is unisegmental. It's coming in at the same segment that it's going out of, the same segment of the cord. And it's on the same side. Ipsilateral means on the same side. It's not in the other leg. So it's the simplest. Monosynaptic, unisegmental, on the same side, ipsilateral. Let's go a little further. The Golgi tendon reflex. Remember where the Golgi tendon was? Down here. The Golgi tendon reflex is the opposite of the stretch because the Golgi tendons work in opposition to the muscle spindles. Okay. Contracting the muscle activates that. Afferent are stimulated. So in other words, if you came in with this, you would put some pressure on that Golgi tendon. When you put pressure on that Golgi tendon, what's it going to do? It's going to send a signal in, but you don't go directly. I need an inhibitory postsynaptic potential. Check me out. What do I need? A negative, an inhibitory. The only way to get it is to hook to an inner neuron. I'll say that again. Because if you go direct, you're going to be back to this one. If you go direct, you're going to be back to this one. So you need an inner neuron. You need to activate the inner neuron. The inner neuron sends an IPSP. The IPSP comes in and relaxes the muscle. Comes in and what relaxes the muscle? Too much stretch. Pushing on it too much. Remember I told you the Golgi tendon works opposite. So what's going to happen is, in this particular case, Golgi tendon is polysynaptic because you needed more than one synapse. It still is coming in at the same area of the cord, so it's unisegmental, and it's still in the same leg, ipsilateral. All right, so let's go to another one here real quickly. The flexor, I'm going to do the flexor. All right, the flexor real quick would be this. You touch something that's hot. You pull your arm back. You flex your arm back. It's like that. You flex your arm back. I touched something hot. Didn't know it was hot. It's not too hot. I flex my arm back. All right. If I flex my arm back, so that's the flexor, then when I flex my arm, which my biceps is going to flex, but I got to relax my triceps. How am I going to do it unless I relax? Because the triceps oppose the bicep. You don't even need to know anatomy to know that. So when I do it, I need an inhibitory. I need to contract one and relax the other. So quite naturally, it's going to need several synapses. Now, the arm, remember we just saw that brachial plexus? See all them nerves going to the arm? That's on several segments. We used the brachial plexus, which was coming off part of the cervical and part of the thoracic. That's several segments. So it's multi-segmental. But it's still on the same side. Still on the same side. So the flexor reflex, the stimulated side is withdrawn. You know what I just said? That's the flexor. The stimulated side. So you touched something. You didn't know it was hot. You pulled back. And you involve the brachial plexus. Right? You had to inhibit some muscles and stimulate others. So you can now see. Then we go to the last one. And the last one is the crossed extensor. All right, here comes the scenario. You reach for something and it is extremely hot. So hot, you jerk back hard. Now let me tell you what's going to happen. When you jerk back hard on your feet, your leg is going to, the leg on the side that you are jerking back is going to flex. But so that you don't fall, what you got to do, extend the other leg. Because you got to rock back on that other leg. Think about it. You don't even have to see me doing it. You're going to jerk back so hard that you're going to rock back on that other leg. Okay? So in that case, you know it's polysynaptic. You're involving arms and legs. You know it's segmental, but think about it. You go into that other side, contralateral. So you really are involved in both that ipsilateral and contralateral. But the key is that cross extensor is very involved. Okay? So that's that cross extensor. You can look at these pictures on your own. So I'm going to now end this one. and close out. Superficial reflexes just when you just rub across your skin.